Okay, rationalize the denominators. Welcome, everybody. We are going to do rationalizing the denominators. And the general idea of what we're doing today is that we need to handle fractions and make fractions look better. When it comes to math, there is some stuff that we're picky about and some stuff that we're not picky about. And we are typically very picky about denominators, okay? When it comes to fractions, the way that you can think about fractions is that, and you don't have to write this if you're in class, but on top we have the number of things. On bottom, we have the number of piles, right? This is how kind of fractions work in general. If you have 15 divided by 5, you can think about this like we have 15 things and you need to put them into 5 piles, right? Like maybe you've got 15 shirts and you need to make 5 piles of shirts. Well, how many shirts are going to end up in each pile? You're going to have 3 shirts in each pile, right? So this is a way to think about fractions and how they work. We run into some issues when we have a strange thing down here for number of piles, right? Like, for example, we do not like when we have 15 objects trying to put them into 0 piles, right? It's like if I gave you 15 shirts and you were holding them in your hands and I said, all right, go ahead and sort these out into 0 piles. You'd just be holding the shirts and you'd start to sweat a little bit, start to freak out like, is this guy crazy? What's he talking about? So we don't like dividing by 0. We don't like other things, right? We don't like if we had some weird kind of question like this. Here's 15 things, put them into 2/3 piles, right? It just doesn't really make sense. We would want to reorganize that so that it made a little bit more sense. We're going to run into the same issue today where we do not like it if we have imaginary piles, okay? If you've got 15 real things and you need to put them into 5 imaginary piles, it's the same issue where you can't put real things into imaginary piles. It just doesn't work at all. You're holding the 15 shirts. There's not any real piles. You don't know what to do. So that's our goal today, is to take a problem denominator like this and turn it into a regular denominator. Now, as much as that's weird, we don't care about the numerator at all. I don't care if there's a weird number in the top, okay? It's not the same problem. I know this might sound hypocritical, but if I give you 5 imaginary shirts and say, put those imaginary shirts into real piles, you might be just like throwing invisible shirts on the ground, but at least you're not stuck with real things trying to put the real things into piles that aren't there. Again, it sounds strange. Maybe it's overcomplicated, the analogy at this point, but let's just do a question here. We don't like this question, okay? The reason is we have 2 real things and we have 8 imaginary piles, and we need to do some sort of black magic and it's not working. So all we need to do is try to take this I and get rid of it, okay? Put it somewhere else. So what strategies do we have to get rid of things, right? Well, when it comes to fractions, what are you allowed to do to change fractions to make them look different? What are some of the rules you can do? Okay, how about this? Can we subtract I? If you have something like 2/4, can you just subtract 1 from the top and subtract 1 from the bottom? Is that going to preserve the fraction if you do subtraction? If we try this out, 2 minus 1 is 1, 4 minus 1 is 3. Is 2/4 the same thing as 1/3? No, this one's a half. This one's less than a half. So you cannot use subtraction when it comes to rebalancing fractions. Okay, so we can't just subtract the I away. What else do you want to try? Multiplication. So obviously, multiplication is something we are allowed to do, right? If I multiply by 3 and I multiply by 3 and I get 6/12, is 2/4 the same thing as 6/12? Yes, this one's a half, this one's a half. And so balancing with multiplication is something that we are allowed to do. So what are we going to multiply by? Okay, and why are we going to multiply by I? Exactly, because I squared equals -1. That is our ticket from the imaginary world back to the real world. Now, something to point out here, our top is going to go from a real number into an imaginary number. But we don't really care about the numerator. We don't really care. It's the denominator that we want to fix. So we get 8i squared in the denominator. Technically, we've made this denominator even more imaginary, but we like that because now we're able to take this I squared. We're able to do a swap for a -1. And remember, it's not 8 minus 1. It would be 8 times -1. And so what we would have is 2i divided by -8. Now, we've accomplished our main objective, okay? We have taken imaginary piles and we've turned them back into real piles. But, as always with fractions, sometimes you can go simplification crazy and you can simplify them all the way down. And so, technically, we don't really like negative denominators either, right? To have a negative number of piles also doesn't really make that much sense. And so we can just kind of pop the negative up to the top. That is a totally legitimate thing to do. You can think about this like multiplying by -1, which will go negative, negative. The bottom will be positive and the top will become negative. Or you can just think about it kind of simplifying it as just put the negative on top, okay? So maybe we like this better, which is simply just putting the negative on top instead of in the bottom. Now, again, these two things are the same. And, you know, we've kind of accomplished our goal of getting rid of the i's in the denominator. So we're kind of happy over here. But it's not the best answer. This one's certainly getting better. And I'm sure some of you are sitting there thinking, can't we make this even better? Because we have a 2 divided by 8. Don't you know that 2 eighths can be reduced? And so technically, the best answer is -I divided by 4, where we've said 2 eighths. That's the same thing as 1/4. And we've made that simplification. So, as far as I'm concerned, this is the skill that we're practicing today, right? This is the new stuff that I want you to be able to do. The I squared and swapping it out for -1. This is the stuff we like. But if this is a test question on the SOL test, maybe even on the test, and you finish it and you get here, and you don't see this, you might have to look for this. Because it's the same thing. This one looks nicer. And if you still don't see this, you might have to go even further until you get to this. And at this point, the answer looks as good as it can possibly look, okay? So more so just an issue of you seeing all of the kind of correct answers and working on it from there. All right, let's do number 2 really quick. Now we have a very easy strategy, right? Multiply by I, that's easy peasy. Then we have the I squared, which gets swapped for a -1. So we get 3i over -5. And that is a good enough answer for scratch work. But on the test, it probably would look more like -3i over +5. So really, that's probably the best answer. Pretty straightforward. Hopefully that feels pretty easy. We could do another question. Let's do one more really quickly. Like number 5, times I. We're going to multiply this. We're going to get 6i divided by -4i squared. We're going to take the I squared, turn it into -1. This one's actually nice because we already have a negative here. And so we're going to have a -4 that gets its sign flipped. So it's going to turn into a +4. So we're going to have 6i over 4. And we don't have to worry about the negatives. But I'm sure you're thinking, I know this can look a little bit nicer. Really, probably the best answer is 3I over 2. Okay, just feeling pretty good, pretty easy. Any questions? You want to see another one or you're good? Okay, let's move it on. Let's see a question like number 7. I know we're just absolutely randomly jumping around the page here, but bear with me. Number 7. Same exact problem. We have an I in the denominator. Same exact strategy will still work. Times I, times I. This is all going to work. On the bottom, we're going to get negative 6I squared. And again, that's not too bad because that I squared is going to be the negative 1, and we already have a negative. So on the bottom, we're going to get positive 6. But it's the top that has given us some weird stuff to handle here, okay? How do we multiply the top by I? Not that hard. You guys have done it before. Did it on Tuesday. Did it for the homework. We just need to distribute this, okay? We've got a double times I. We've just got to make sure that we multiply I by both of them. And so on top, we will get 4I minus 9I squared. And make sure that you're multiplying the I by both pieces. And it's not that much more complicated, but it is a little bit different, right? The I squared is going to get swapped. It's going to turn our negative 9 into a positive 9. And so sorting out the top, and I'll do a little rearranging as well. I'll put the real number first, because when it comes to these imaginary numbers, and specifically these complex numbers that are partly real, partly imaginary, we like the real part to go first, okay? So if your answer looks like this, 4I plus 9, that it's still the same thing, but this one is just a little bit better. It's just a little bit cleaner because we have the real number coming first. So it's all the same strategy, just distributing the I. That's not too bad. Let's do one more really quick, and then let's just cruise. Let's do number 9. Sure, same problem. Times I, times I. We need to distribute the I on top. On bottom, we're going to get negative I squared. On top, we're going to get negative I plus 8I squared. Both of these are going to get swapped up. And so when I'm done, I'm going to get, this is going to be negative 8, but let's put that first. Negative 8 minus I. On bottom, we're going to have negative 1 times negative 1. So we should have positive 1. And same thing with this one. You don't really have to divide by a positive 1. So really probably the best answer just looks like this. Negative 8 minus I. That's probably the best way to write your answer for this question. Okay, handling these, do we have any issues? Are we doing okay with these questions? You know, we have, in order to get rid of the imaginary numbers on the bottom, just multiply by I. No problem. Now, cruising along, let's do question number 12 here. Again, sorry, we're just randomly bopping around, but we'll be all right. We have a question like this, okay? And we have a complex denominator now instead of a imaginary bottom. We have a binomial in the denominator. And before you write this down, just watch me do this for a second. If we try our same strategy, okay, and we get 8I squared on top, that's easy. On bottom, we need to distribute. We are going to, same idea, right? Be able to get rid of our I and turn it into a negative 1. Actually, not really, because this I is still on the bottom. When we distribute this I, it's going to get stuck, and this I cannot be removed, okay? If I, again, I'm going to keep going. Don't do this necessarily, though. And that's going to be a plus 3 that turns negative, so it's going to be a minus 3. I'm stuck with this I. And if I want to get rid of it, and I multiply by another I, that one's going to be an I squared. That one is going to be negative 3I, which I'm not going to be able to get rid of. And so we get stuck in this infinite loop of not being able to get rid of our denominator by multiplying by I. So all of this work is completely useless and completely futile, and all of this work that I did and hopefully you did not do was a waste of time. So multiplying by I does not work. This will not turn our denominator into a real number. It will not realize our bottom, which is not a word. So what's our strategy? We cannot divide by I. What are we going to do? You guys in class, you got a little bit of a sneak peek as to what we're going to do. What are we going to do? Just like Joey said, we're only allowed to multiply top and bottom. That is it. So we need to multiply this. Oh, now I'm writing in white ink. We need to multiply this by something that will take away all the i's. And again, you guys got a little sneak peek in class, and it's literally written on the board over there. We're going to utilize conjugates, right? It's up here on the board if you're in class. Conjugates, okay? This sneaky, difference of squares looking thing is a way that we can totally eliminate all of the i's from a binomial, from a complex number. And so we're going to take this binomial, we're going to have to multiply it by another binomial that looks very similar, -1, 3i. We're going to use all the same numbers. The only thing is that we need opposite signs in the middle. So if we've got a plus 3i, we need to choose a negative 3i over here. These two things, again, it's on the board for those of you in class, but these two things are conjugates. Okay? They're binomials with opposite sides. And it's going to work a lot like difference of squares. We're going to have to do a FOIL here. We're going to get +1, +3i, -3i, -9i squared. We did this little foiling action here. And this is exactly what we wanted, okay? This I squared is going away. That's going to get swapped out. That's going to make a +9, because it was a -9. And then these things here, all of our leftover i's, actually are not going to be left over because we have a +3 and a -3, and those two things are going to cancel out. So using conjugates here has been the perfect solution. We still need to remember this 1. Still going to be 1 down here, but it's just 1 + 9, and so we've got 10. 10 piles in the denominator. We've been able to go from a complex number to just a straight up 10. Now, unfortunately, that's only half the question here, right? We still need to handle the top, and whatever you multiply by the bottom, you've also got to multiply by the top. So we still need this -1, -3i. And while the bottom was kind of magical and it just worked out, perfect, right? And we were very happy. We saw something very cool happen on top. There's nothing special about the top. This is just two random things multiplied together. So don't expect the same fireworks when you multiply the top. We need to distribute the top. We're going to get -8i. We're going to get -24i squared. We are going to be able to swap out the I squared. Give myself a little bit more room. And so, let's pick this color. And so our final answer here, this is going to become a positive 24. And so I'll write that first as well to kind of reorder it. Minus 8i, that's the top, divided by 10. That is our strategy to normalize the bottom, to turn the bottom into a real number. And again, as far as the numerator goes, as far as the top goes, we don't really care. Now, technically, we get stuck doing this all day. Technically, this answer could be better. We've got 24 and 8 and 10. We've got these three numbers. And if all three of these numbers can be reduced, we're able to reduce these fractions. Is there any number that is a factor of 24 and 8 and 10? 2, of course. And so we can half all these numbers, okay, and we can get 12 minus 4i over 5. This is the best answer. This answer is still pretty good. I'm still pretty happy if you can get this far. Actually, I'm still really happy if you can get this far. But on the test, if this is the only thing that you see, you need to know that they're the same thing, right? It's reducing fractions. And this is definitely a more complicated way to reduce them because you've got three numbers to consider. And they all have to be reduced the same amount. They all have to be reduced the same amount. So let's see conjugates in action one more time. I think you're going to be flipping over to the back. Let's do a question like number 15. I don't know why we're choosing 15, but we're choosing it. So we need conjugates. A regular old I will not work. We need to think of this denominator as a complex number. We need to choose the complex conjugate that is pretty much the exact same thing with a different sign in the middle. So what's the conjugate? Somebody shout it out. Negative 3 plus 6i. Boy, genius. Very good job. Jimmy Neutron, that's right. You having a brain blast over there, buddy? So we're going to handle this. This is the complex conjugate. When we FOIL these, we should see just some beautiful mathematics happen. We get 9. We get minus 18i. We get plus 18i. We get minus 36i squared. And this is just perfect, right? We love the I squared. That's making a swap. We love the minus 18 plus 18. That's getting deleted. And so we have 9, and this is plus 36. So on the bottom, we have 45. Pretty big number here. On top, we're not going to expect anything spectacular. We're just going to do some normal distributing. We're going to get negative 12, and we're going to get 24i. And that looks pretty good right off the bat. We've got our stuff in the right order. We don't have any I squareds that we need to sort out. We don't have any negatives on the bottom. So we're liking this for the most part. But is there any way that 12 and 24 and 45 can be reduced? Maybe not. But is there any number that can be divided by all three of those? 45 divides by 3, what do you get? Nope.
Oh my god, that was so bad.
It's not that bad.
Yeah, that's pretty bad.
What's 45 divided by 3? 15. That's all right. Hey, you said it quickly and confidently, and hey, that's what really matters. Yes, we can divide all three of these by 3. And so technically this is the best answer. I'm still pretty happy if you can get this far. I'm still pretty happy. But this one is very happy, right? 2 smiley faces. How's that? Very weird. So, feeling pretty good here. Any questions about conjugates and how to choose them and why they work? Let's do one last one. We're doing one very last question. Give me a number, 17, 18, 19, 20. Which one do you want to do? Okay, 19. Great choice. 19. We're doing one of these because this is kind of the ultimate question when it comes to rationalizing the denominator. We need to choose the complex conjugate 7 plus 10i. We need to make sure that we are multiplying the top and the bottom by the same thing. Now, students can get a little confused here, right? Because they'll think, well, wait a second. If I multiply the top by the top's conjugate, I could get the top. We don't care about the top. Okay, we just want the denominator to have no i's in it. Okay, we can't fix them both at the same time. We're just going to fix the bottom, leave the top alone. So, handling this, (49 minus 70i plus 70i minus 100i squared. We're loving it. I squared minus 70 plus 70, 49 plus 100. Beautiful, right? Chef's kiss. Now on top, we have another foiling to do because it's complex by complex. It's binomial by binomial. So we're not, we still have our work cut out for us. And again, this is not going to be some sort of beautiful conjugate multiplication. These are just two random complex pairs being multiplied. Same kind of thing. These two will combine. This one will disappear. And so this is going to be negative 35. This is going to be positive 30. So that's going to be negative 5. This one's going to be negative 50. This one's going to be negative 21. So that's going to be negative 71. Whew. An excellent question. Great pick. That's as good as it gets, I promise you. 149 is a prime number. All right. That is rationalizing the denominator. Okay? It is complicated in its own way because you need to choose a very specific thing. You have to pick the perfect conjugate. The good news is picking a conjugate is very easy. Okay? It's the same exact complex number with a different sign in the middle. Once we do that, we get this beautiful kind of thing that works out. Everything crosses out. The I squared goes away. And we're able to get an answer with a real number of piles. Again, the top number, who cares about the top number? The bottom number needs to be no i's. And so we feel pretty good. There's a lot we didn't do, of course. Don't worry about it. Make sure you still know how to do the easy questions. Make sure you still know how to do the distribute questions. I know these bottom ones, everyone loves foiling, but make sure you know how to do the regular ones too. All right, that is it. Let me stop this recording.